Today we're going to be looking at quadratic equations and their graphs. Now, quadratic equations we've used in the past and we've been using currently have an equation that looks something like this. This is called standard form for a quadratic equation. We have y equals ax squared plus bx plus c. Now remember, instead of y, you may see f of x instead, which means the function of x equals this. Y is the same as f of x, or the function of x. Now, what makes this a quadratic equation, the way that you can tell you're dealing with a quadratic equation, is that your highest degree monomial is squared. So you have an x squared, or one of your variables is squared. Here's some examples I wrote. Y equals 3x squared, that's quadratic. Y equals x squared plus 9, it's a quadratic equation. And then y equals x squared minus x minus 2, that's a quadratic equation. Now what we're going to do today is we're going to graph them. So our first example, just a simple one, y equals x squared. What we're going to do is we're going to set up a function table, just like we used with linear equations. We'll plug in a value for x, and then we'll find out what y, the output, would be. So our domain, remember the word domain, is x, and our range will be y. So let's just choose a few values, and what I like to do is I like to start with 0, and then we'll use 1 and 2 to plug in for x. Now, x squared, which would give us y, 0 squared is still 0. If we plug in a 1 for x, we have 1 squared, which equals 1. And if we plug in a 2 for x, we have 2 squared, which equals 4. Now, the ordered pairs then would be 0, 0, 1, 1, and 2, 4. Now let's go ahead and plot these. We have 0, 0, which is right at the origin. 1, 1 is here. And then 2, 4 will be all the way up here. Now, it's hard to tell with this graph, but you can kind of tell, and especially if you plug this in your calculator or if you draw it on your own. This gives you doesn't give you a straight line. It starts to be a curve to the line, and it'll go up like that. Now, what happens if we were to put in negative numbers for our x values? If I put in negative numbers, let me go ahead and erase these real quick. Let's put in a negative 1 for x. Then we'd have negative 1 squared. What about a negative 2? We'd have negative 2 squared. Negative 1 squared is 1. Negative 2 squared is 4. So our ordered pair would be negative 1, 1, negative 2, 4. Now if we plot those over here, we have negative 1, 1, and negative 2, 4. And as you can see, it creates sort of a mirrored image on the other side. And this is a complete curve. This shape is called a parabola. The curved shape is a parabola. Now this parabola, as you can tell, opens upward. Parabolas can open upward or downward. Can actually open sideways also. We'll get to that later. But right now, I want you to notice this is upward. Now, there are certain parts of this parabola that you need to know. The very, very bottom point where it makes its curve, this is called a vertex. Kind of like with angles, you have the vertex where the two lines meet. This is called the vertex. Now this is also called, it has another name, it's called the minimum point. Now if this parabola was to open downward and it looked like this, we would still have a vertex, but that would be called a maximum point. So we can have a minimum point or a maximum point, meaning that's as low as our y value. Notice on the y-axis, it never goes lower than 0. It goes down to 0 and goes back up. So that's called a minimum point. If it was to go the other way, if we had it going this way and it was opening downward, the highest point it would go would be called the maximum point. Okay, so we have a vertex and a minimum point. Now also, there's something called an axis of symmetry. The axis of symmetry is the line you could draw that would divide this in half to make two mirror images. And right now the axis of symmetry runs right along the y-axis. So this here is the axis of symmetry.